Okay, we have here an interesting integral. This one's from Columbia Integration Bee 2024, number 22. We have the integral from minus infinity to infinity, 1 over x squared plus pi x plus pi squared dx. Okay, to get started with it, even though it's kind of weird having pi as our constants, I want to do something pretty normal with it and just complete the square. So what we can do, if I do x plus pi over 2 and we square that, we get x squared. The middle terms create this pi x. Then the last term creates pi squared over 4. So to be kind of careful about it, let's subtract off this pi squared over 4, so we're not changing it, but we still have this plus pi squared here. I can write that as 4 pi squared over 4 pi squared. Then putting together all of our constants, what we're left with here is going to be plus now 3 pi squared over, oh, what did I do? Oh, sorry, that doesn't need to be a pi squared there. I was just creating the 4 to create a common denominator. So then putting them together, 3 pi squared all over 4. But the way I'll write it, let's write this as square root of 3 pi over 2 all squared, just creating it as a perfect square. So we'll take this and plug it back into our integral. So now we're going minus infinity to infinity dx over x plus pi over 2 squared plus square root of 3 pi over 2 all squared. And then from here, you'll notice we don't need a u substitution just because the derivative of this is going to be 1. If we do a u substitution on this, we just get du equals dx. I'm going to do it out anyway, just for housekeeping, just so you can see it. But if you're doing it on paper, you can just skip that and you don't need to waste your time, but it's just to make it clear. So real quick, we'll say u equals this and du equals dx, and we'll just go ahead because, again, the bounds don't change because we're going to infinity, so it's still this kind of thing. We have du here, it becomes u squared. One other thing I'm going to do just to save writing, let's call this thing an a value, just because now that we have it written as a square, it doesn't really matter what it is. So we have a squared, and we'll come back later and plug in this value. But then you'll notice this is exactly the arctan integral. One thing I'm going to do before integrating, let's use the principle of even functions on it. We're symmetric around 0, so I can change this to 0 and bring a 2 out front. Go ahead and integrate. We've got our 2 out front. The formula for this is going to be 1 over a arctan of u over a. But let's put it back because we know what our a is. So again, this is going to be square root of 3 pi over 2. Let's take the 2 and flip it because we're in the denominator and bring it up here. So we'll just write it like that for now. We'll kind of flip it again here. So I can flip the 2 and write it as 2u over square root of 3 pi. And we just need to evaluate this from 0 to infinity. Now when you plug in 0, arctan at 0 is nothing. So that goes away. Plugging in infinity, we don't really care about any of the constants here because when this is going to infinity, arctan is going to be going to pi over 2. So what we're going to have is 4 over square root of 3 pi times pi over 2. Cancel out pi's here, cancel 2 with 4, and we get a 2. And so for my final solution on it, we just get 2 over square root of 3, and that's it. Okay, there you go. Good one from Columbia 2024. Thanks everyone for watching. Have a good day.